In this video, we'll talk about solving quadratics by factoring. So something that's useful to kind of discuss is, I guess there's two real uses for this skill. Number one would just be solving an equation with a quadratic term, so with an x squared term. Another use would be trying to find the roots or zeros or x-intercepts. They all mean the same thing of a quadratic equation. And something that's worth noting in these is that sometimes, depending on your quadratic, you may have one real solution. So that'd be if it comes down and it just grazes the x-axis. Basically, when I'm saying y equals 0, that's what a root is, what an x-intercept is, what a 0 is. Another case would be I have two roots. So my quadratic could come up and then come back down and crosses it twice. Or it could have no real roots. It might not cross at all, just due to the nature of the parabola. So this is worth keeping in mind. Sometimes you can work this down and you won't get anything that makes sense. You'll be trying to take the square root of a negative number, which is something that we don't have the power to do. So let's dive right in. Let's just go ahead and try and solve an equation first. I think that would be our simplest way of looking at it. So if we're looking at this, we have x squared minus or plus 12x equals negative 12. Now, with it being what it is, if we move the 7x over, we can't really take a square root because then we still have an x on the other side. We can't really factor out an x because then we have an x times x plus 7, and then what do? So we're kind of stuck, almost. So there is a simple rule in mathematics. If a times b equals 0, then this tells me that either a equals 0 or being the operative word, b equals 0. So this is kind of our key thought when we're talking about factoring. And it might seem a little strange now, but just bear with me here. The first thing I'm going to do is I'm going to add 12 to both sides. So x squared plus 7x plus 12 is equal to 0. Now, why did I do that? Well, I'm going to try and set this equal to 0, and I'm going to try and factor this thing, essentially rewriting it as a product of two things. One thing times another thing, a times b. And if I can do that, then I can rewrite, or I can solve those individual pieces for 0. So a way of thinking about this, we have to factor this expression. So we have to think of it as we're basically reverse foiling or reverse double distributing or reverse smiley guying this thing. So the whole idea here is we're going to look at the factors of our constant term, in this case 12, and we're going to write out the factors. Remember, factor is the two things that multiply to make the thing. So 1 and 12, 6, 2, 3, 4. Those are the only ones I can think of right now. And then these things have to add to make 7 in this case, because both the signs are positive. My next step is going to look something like I have x's, and I'm going to have extra terms in here. So in this case, 3 and 4 both add to make 7. So x plus 3 and x plus 4. If you're not sure, feel free to FOIL this thing out and just check. Make sure that you get the same thing up here. Now, if you are cool with this, if you accept that this is true, then I can say, well, if this is true, x plus 3 has to equal 0. Or x plus 4 has to equal 0. One of these two things must be true. So x equals negative 3 or x equals negative 4. Now for now, that's as good as I can go until I have context. One of these might be able to be eliminated with context. So at the moment, I don't know which. However, I've narrowed it down to two possibilities. And at this point, I'm done. So let's take a look at finding the roots. Now remember, a root is an x-intercept or a 0. They all mean the same thing. I don't know why they have 3 different terms for the same thing. Basically, if I'm looking for a root, I'm trying to figure out how many times does this thing cross and where are they? That's what they're asking for. So in this case, my solution is not going to be an or, it's going to be an and. I want both of these things. But we're going to solve it very much the same way. Now you might be noticing here, on this line, y equals 0. So I can just go ahead and say, oh, well, f of x must be 0. So 0 equals x squared plus 2x minus 3. Now again, I'm going to factor. Because it's equal to 0, I can rewrite it as a product of two things and say that one of the two must be 0. So I'm going to look at the negative 3 here. Factors of negative 3. Well, 3 is prime, so that tells me 1 and 3, but one of them must be negative. Just one. So the question then becomes, is it the 3 or is it the 1? Now I want them to make a positive 2 when I add them up. So I'll have x, I'll have another x, and that'll mean I'm thinking the 3 has to be positive. Plus 3 minus 1. So 3 minus a 1 makes positive 2. Now again, if you have any doubts, if you're not sure whether you did this step right, you can always FOIL it out and you should get the same thing. If you get the same thing, you know you did it right. So at this point I can say x plus 3 equals 0 or x minus 1 equals 0, which tells me x equals negative 3 and x equals 1. Now, what the difference is here, since we're talking about roots, we're going to have roots at both those points. So this is the case where it crosses twice, and it happens once at negative 3 and it happens once at 1. So in this case, since we're asking about the roots, we will use the term and. However, if I'm solving, I will only use the term or, because we just don't know which one we're talking about yet.